Dear all, welcome back to the playlist of Basic Electrical Engineering. In this video, I will be discussing analysis of AC circuit with a pure inductor. Do you know what is inductor? Where it can be used? First, let us understand the importance of inductor. In radio tuning circuit, there are different filters and also different type of regulators. The inductors are being employed. So you can able to see this is the way how inductor look like. It is basically a coil with a suitable insulation. Okay, in between the coil there are insulators. Some inductor we can see the core also. Some inductor without core. Let us understand what is an inductor. How does it work? An inductor is also called a coil, or you can call it as a choke, or you can call it as a reactor, which is a passive two-terminal electrical component that stores energy from magnetic field when the current flow through it, or current pass through it. It stores energy from the magnetic field when the current flows through it. An inductor is typically comprises of insulated wire wound into a coil around a core, as shown in the diagram. And also, how does it work? It works based on the Faraday's laws of electromagnetic induction. Kindly refer the previous video to get the information about Faraday's laws of electromagnetic induction, that I will be placing in both description box and I button. When a current, suppose when the current flowing through the inductor, what is going to happen? The value of inductance changes. The time varying magnetic field induces an electromotive force, you can call it as a EMF, or in a conductor, that describes by Faraday's laws of electromagnetic induction. The induced EMF that is going to generate inside the inductive coil. That induced EMF is also known as back EMF. Okay, the thing is, the induced EMF or induced voltage or back EMF, that change in the current, okay, that opposes the change in the current which is flowing through the particular inductive coil. It may be change in the sense it prevents the rise in current and falls in current. Okay, whatever the EMF which is induced in the coil, that going to oppose the change of current. That is another speciality. So this is actually happening due to the Lenz rule. You have to recall what is the Lenz rule. Okay, it is based on the Lenz rule. Finally, inductor opposes any changes in current through the particular coil. Suppose due to the induced EMF, it opposes the induced EMF. Due to the presence of induced EMF, it opposes the rise or fall of current through the inductor. That is another speciality. There are different type of inductors, as you can able to see. What you can call this is a normal symbol of inductor, representation of inductor. See, like this. Basically, these inductors are called air core inductor. Okay, there is no particular material like iron or some other material. It is a purely based on air core inductor. Okay, medium is air. Then you can see the variable inductor. Then iron core inductor will be represented in this fashion. The core will be used as iron. Here also iron core inductor. You can see the iron core inductor. Ferrite material. It is made up of ferrite material. Core is made up of ferrite material. In the International System of Unit or SI unit, International System Unit is also known as SI unit. The unit of inductance is Henry. The core can be used as iron or ferrite, or simply it is an air. Applications I have mentioned already: filters, power supplies, radio tuned circuit, impedance matching circuits, etc. The following factors are depending on the value of inductance: the shape of the coil, how many number of turns you are going to provide, n number of turns, then permeability of the core material, permeability of air or permeability of ferrite core or permeability of iron, etc. And the size of the courses also matters a lot. These are the various factors which are depending on the inductor. How does it work? Whenever an AC voltage is applied to a pure inductive coil, a back EMF, or you can call it as an induced EMF, which is produced due to self-inductance of the coil. This back EMF at every step opposes the change in current through the coil. It may be either rise or fall in current. There is no ohmic voltage drop. The applied voltage has to overcome the self-inductance EMF only, self-induced EMF only. So there is no ohmic voltage drop which is happening in case of pure inductor. So this is actually happening in case of inductor. Let us understand when you connect an AC supply to the inductor. First of all, according to Faraday's laws of electromagnetic induction, we can write V is equal to L di by dt, where V is the induced voltage across the EMF or self-induced EMF. Call it as equation number 1. As we know that the sinusoidal voltage can be represented equal to Vm sin omega t, and please call it as equation number 2. Equating 1 and 2, how we can able to write the L di by dt can be equated to Vm sin omega t, same manner, or we can write it as Vm sin omega t is equal to di by dt. Is it clear or not? Vm sin omega t is equal to L into di by dt. Here L is missing, we can write it as L. Okay, L into di by dt. L is missing here. Please update with this value. From this, you please calculate. You can calculate dA. How to separate dA? So dA can be written as Vm by L. L can be taken into LHS. dA is equal to Vm by L into sin omega t. This is the change in value of current. Okay, so I need to calculate the total change in value of current. So integrate at the LHS side and RHS. Whenever I am integrating, I will be getting like integral of dA. Integral of dA is nothing but I. Then integral of Vm by L into sin omega t. Vm by L is a constant value, so let me take it as outside. Vm by L into integral of sin omega t. So Vm by here, when I am going to integrate, omega will come down, right? So Vm by omega L into minus cos omega t. Clear? Later on, I'll be modifying minus, I will be taking outside, minus of Vm by omega L into cos omega t. Hope it is clear. Thereafter, what I am going to do is, according to trigonometric relation, cos omega t can be written as sin omega t minus pi by 2. Thereby, what I can write? See, cos omega t is equal to, what I can write? Sin omega t minus pi by 2. But sin omega t minus pi by 2 is equal to minus of cos omega t. I hope you understood. Okay, that trigonometric relation you have to follow. Thereby, minus and minus both will be getting cancelled. There I can write it as I is equal to Vm into L omega into sin omega t minus pi by 2. I think it is clear. So please note down this. I is equal to Vm by omega L into sin omega t minus pi by 2. So we have got the equation. V is equal to, compare these two equations. The first equation is V is equal to Vm sin omega t. The second equation is equal to I is equal to Vm by omega L into sin omega t minus pi by 2. So from this equation we will come to know that current is lagging here. Look at this. Current is lagging. I can able to write the phasor diagram. So current is lagging behind the voltage, or you can call it as voltage is leading. For a pure inductive circuit, current is lagging behind the voltage at an angle of 90 degree or pi by 2 radian. So that is a clear information from this particular diagram. See, I can be written as Im sin omega t minus pi by 2, where V is equal to Vm sin omega t. From this we will understand that, we will come to know that for a pure inductive circuit, voltage is leading the current at an angle of 90 degree, or current is lagging behind the voltage at an angle of 90 degree. This diagram represents, this is your voltage. See, voltage is starting at 0 degree, but what about current? It is not starting from 0. Obviously, there is a, for pure inductor, there is a phase difference of current and voltage of 90 degree. Phase difference between current and voltage is equal to pi by 2 radian or 90 degree. It is very clear. Or else I can represent, if I take the voltage as a reference, you have to draw the current in this manner. The angle between voltage and current should be 90 degree. Applicable for ideal case, for real ideal case. For the practical case, this is not possible, but ideal case you can represent it in this fashion. So here I will be representing in another manner. Current is taken as a reference. If I take the current as a reference, then how do you represent voltage? Voltage is equal to Vm sin omega t plus 90 degree. Okay. Regarding the instantaneous power, so you can calculate the instantaneous power by using the formula Vrms into Irms. Vrms is nothing but Vm sin omega t, where Irms is equal to Im into sin omega t minus pi by 2. So sin omega t minus pi by 2 is equal to minus cos omega t. So minus come over here. Vm Im sin omega t into cos omega t. So you have to recall the formula sin 2a is equal to 2 sin a cos a. Same manner you can apply here. Vm Im by 2 into sin 2 omega t. You have to put minus. Then if you take the integration, then we will come to know that the power for complete cycle is equal to 0. So power is sin the power consumed by the inductive circuit, that is equal to 0. The maximum instantaneous value of power can be written as Vm Im by T. But average demand of the power from the supply for the complete cycle is equal to 0. You can